Our project was a least squares classification model for recidivism. We were looking at the racial bias in it. Courts and police forces want to be able to predict whether a person convicted of a crime will commit another crime. In other words, whether they'll recidivate. And they want to know that so that they can determine changes to the person's sentence, or whether they get bail or parole. An organization called North Point created a test called Compas, which was meant to predict whether a person would recidivate. Another organization called ProPublica found that Compass's test had a racial bias. When we say a test was racially biased, we mean that it had a significantly greater rate of false positives for some races compared to others, much higher rate of false positives among black people than white people. ProPublica found that the Compass DataSet test had a 43% false positive rate among black people compared to 23% for white people. It also had a 48% false negative rate among white people compared to 21% for black people. We also want a model that's accurate overall, that lacks a high false positive rate in general. We don't want people being punished for crimes that not only that they haven't committed yet, but will never commit. And we want our test not to have that discrepancy in the false positive and false negative rates. So our question was, can we write a least squares model without that bias? That is to say, without that, we want our model to have a lower false positive rate and more equal false positive rate as than the Compass one, and a more equal false negative rate than the Compass one.
So here are the confusion matrices for our models divided for each race as well as overall. The quadrants of a confusion matrix corresponds to whether the model predicted a defendant would recidivate and whether the defendant actually did recidivate. We also list the plain accuracy of the model for each race. So for the whole test data set, the model with race had about 68% accuracy rate, which isn't great, but still better than the Compass dataset. It also had a roughly 3% false positive rate, and it had a 90% false negative rate when predicting recidivism for African Americans, with a 97% false negative rate for Caucasians. The model without race had roughly 1% better accuracy across the board. It overall predicted more recidivism, which led to an overall higher false positive rate than the model with race, especially for African Americans. It also had an 82% false negative rate for the African Americans compared to a 89% for Caucasians.
So now we come to a conclusion. With or without race, our models do much better on all of the metrics. We care about accuracy, false positives, false positive comparisons, and false negative comparisons than the Compass test. The model that includes race predicts recidivism less often in general than the model that doesn't include race. This leads to fewer false positive but more false negatives. It also consistently has a slightly better accuracy, but that might be anomalous or dependent on the shuffling of the test data set. So there are also few unnecessary feature columns we found in the Compass data sets, which we think we could be avoided, and that could lead to a better accuracy.